going to be walking through another project today. I'm going to be doing the step-by-step walkthrough of build an AI security scanner with Gemini. In this project, we're going to be building a CLI tool that uses Gemini's AI to scan Python code for security vulnerabilities and provide color-coded severity ratings. The difficulty of this project is written as easy peasy. Certainly a great beginner project if you haven't written or used Python code before, and using the Gemini API alongside this. Great place to start. Should take about 60 minutes. Definitely do it in a lot less if you're really comfortable with Python and using Gemini for stuff like this. But we'll be doing this step by step, so it'll probably take us about an hour. Some related projects are building a mini Spotify with Cursor. That's great if you haven't used a AI IDE before. We're going to be using that today. There's also a prompt engineering project. Great for some of the prompts that we're using inside of our security scanner. And then threat detection with guard duty. Similar concepts. So great idea to do those. But you don't need any of them to do this project for sure. Key concepts here: Google Gemini API. That's Google's LLM, large language model, and the API is an application interface we're going to be using to talk to it. We're going to be writing in the language Python, and another key concept is obviously security vulnerabilities generally in code. This project aims to cover that, not just for Python code, say, but just general topics. So, yeah, good key concepts to take away. So, 30-second summary. Security teams at companies like Google, DeepMind, OpenAI, and Sync all use AI to detect code vulnerabilities before they reach production. So this is like, imagine you're running a scanner that instantly spots any SQL injection, hard-coded secrets, and weak cryptography, just like enterprise security tools, but built by you. Most developers don't catch these issues until code review or worse in production. You could manually audit every line, read security reports, hope for the best, or you could automate it. That's what we're doing today. Professional teams use AI-powered scanners, tools that analyze code instantly, write code, run the scanner, see vulnerabilities with severity ratings, all automated, all catching issues before they become breaches. What you'll build. In this project, you'll use Gemini API to build a security scanner that detects vulnerabilities in Python code with color-coded severity ratings. Is Gemini's API free? Yes, the Gemini API has a generous free tier that's more than enough for this project. You won't need a credit card to get started. It's great. Why use Gemini for security? Gemini is trained on millions of code examples and security patterns. It can spot vulnerabilities that simple pattern matching misses, like context-dependent SQL injection or subtle cryptographic weaknesses. Professional security tools use similar AI models to augment static analysis. So if you're new to security scanning, you don't need any other prior research or experience for this to do this project. It teaches how to connect Gemini and craft prompts that detect real vulnerabilities. Cool. Yeah, great place to start, and really a great place to start with using AI models to review code. But also a great place to start with just understanding what vulnerable code could look like, what you should write, what you shouldn't. We'll be going into that pretty in depth, or at least like in depth for a beginner in this project. So if you're not sure if this project is matching your goals, you can use the ask feature here. Send off a message and see if it thinks it's a good option for you to go ahead and do. So we can see how you'll build it. First, you'll connect to Gemini API and test basic code analysis. Then you'll build a scanner that detects vulnerabilities with severity ratings and colored output. By the end of the project, you'll have a working CLI tool that uses AI to find security issues, a deeper understanding of SQL injection, hard-coded secrets, and weak cryptography. And then the secret mission includes file scanning capability for Python files, so you'll be able to hand in any sort of Python file you have, and it's going to go through and pull out some security vulnerabilities if there are any, and suggest fixes. So, a genuinely useful tool as well as this project, just getting you to understand, what to look for, what is a vulnerability. Yeah, for sure. Cool. So this is sort of the block diagram here, what we're going to be achieving with the end file and vulnerable code in the script we're making that utilizes the Gemini API, produces a vulnerability report inside the terminal display. Cool. In this project, I'm going to build a CLI tool. It's a command line interface tool that allows me to understand code that could be should we say could be vulnerable to attacks, I guess. That's a good way to put it. So we can see here, using the definition feature, code vulnerabilities are flaws or weaknesses in software code that an attacker can exploit to compromise a system's security, leading to unauthorized access, data breaches, or system crashes. Definitely recommend using the definitions feature if you ever get stuck. That could be vulnerable to attacks, resulting in future crashes. Yeah, so, definitely a real good project to do if you're getting into the cybersecurity space. I think it'd be amazing to have something like this on your on like a project list. It would be great. So this will help me learn what does vulnerable code look like, how to use the Gemini API, and how to fix vulnerable code. I'm interested in this because companies like Google and Sync utilize AI to spot code early so that they don't become a larger problem in production. Cool, so what are we doing in this project? In this project, I'm going to build a CLI tool that allows me to understand code that could be vulnerable to attacks, resulting in future crashes. Future faults, keep it general. This will help me learn what does vulnerable code look like, how to use the Gemini API, and how to fix vulnerable code. I'm interested in this because companies like Google and Sync utilize AI to spot vulnerabilities in code early so they don't have to become a larger problem in production. Cool. a little bit. We'll come back to this quiz at the end, but you can totally do it at the start if you want to. Okay, so we're going to be walking through the step-by-step guidance version here. There's low and no touch. If you feel you want less guidance, we're walking through the full step-by-step guidance today. So first part is going to be connecting to the Gemini API. So security teams at companies like Google DeepMind use and OpenAI use AI to analyze millions of lines of code for vulnerabilities. Time to connect Google Gemini's API so you can do the same. You'll get an API key, set up Python, and send your first request to Gemini. Awesome. So in this step, get ready to create a new project folder and set up Python environment. Get your Google AI API key, set up an end file, and then test your connection with Gemini. What are we doing in this step? In this step, I'm setting up the Gemini API connection. This involves creating an end file and adding the Gemini API key to it. I need to do this so I can test and verify my connection to Gemini. What are we doing in this step? In this step, I'm setting up the Gemini API connection. This involves creating a .env file and adding the Gemini API key to it. I need to do this so I can test and verify my connection to Gemini. Cool. Sweet. So now we're jumping into actually doing this project inside of Cursor. So I'll open this up in sort of a split screen view, so we can actually see both Cursor, the IDE we're going to be using for this project, and the project on Nextwork, so we can follow along. Cursor does take a little bit of time to open sometimes, that's okay. Cool. All right. So we're going to open Cursor. Let's start by setting up your project folder and opening it in your text editor. Yeah, if you don't have Cursor, that's fine. You can use others. We're going to be walking through with Cursor though. Cool. So we'll open project to desktop and create a new folder. We'll call this security scanner, and we'll open that folder. Cool. So now we're going to set up our Python environment. You can use shortcuts. So you can go to open terminal, you can do Control Shift apostrophe to open it up, or you can go into terminal by taking the ellipses down to terminal and clicking new terminal. Either one work here. So yeah, we'll just check if Python is installed. I do have it installed. If you don't, there is a guide there for going through and setting Python up. So if you need to do that, it's totally all good. Goes through all the steps there. Sweet. So what we'll do now is create a virtual environment inside of Python. We'll run python-m venv. The second venv is just naming it to venv, or venv. So just give that a second. It can take 15 or 20 seconds to do that. What is a virtual environment? A virtual environment is like a separate workspace for your Python project. It keeps all your project packages isolated from other projects so they don't interfere with each other. Think of it as a sandbox where you can install whatever you need without affecting your computer's main Python setup. So the packages I install in this project that I'm doing right now won't be installed globally to my computer. They will only be accessible inside of this project, this directory, where Venv is assigned. So that's really useful. It can be a bit tricky to set up initially with to understand why you want to set that up, because it feels like you'd always want all of the Python packages, but often you'll have conflicting ones that don't align with one another if you're installing all of them globally. So yeah, really good idea to do this. You can use UV, you can use this native Python virtual environment setup. Either one. UV's another Python package manager that lets you just do the similar thing. Yeah, cool. And then we have to go and actually activate, so we're working inside of this virtual environment in the directory. So we can run the command venv scripts activate on Windows. There's an equivalent command on Mac there. Cool, so we can see the virtual environment tag has popped up. So that means we're active in the virtual environment. Cool, so now we can install, using pip, the Google generative AI package that will allow us to actually use the Gemini API key that we're going to get shortly. So we'll send this off. This will take a little bit of time to go install, maybe 30 seconds or so. So what is pip? Pip is a Python package installer. It downloads and installs packages from the Python package index, PI, which is like an app store for Python libraries. When you run pip install Google generative AI, pip finds the package, downloads it along with any dependencies it needs, and installs everything in your virtual environment. This makes it easy to add functionality to your Python project without writing everything from scratch. Yeah, exactly. Just a package index for the language Python is what pip is. You have plenty of other ones for Python, as well as obviously for other languages like C. Well, plenty of libraries for C, or any language. It's no different. So what is the Google Generative AI SDK? That's SDK is Software Development Kit. The Google Generative AI package is Google's official Python package for interacting with Gemini models. We can see the package is finished installing now. It handles all the complexity of connecting to Google servers and verifying your identity with the API key instead of writing raw API calls. You can use simple Python methods like model generate content to send prompts and get AI generated responses. Yeah, I'll be using that this generate content thing shortly. So it's successfully installed, so I'm going to follow down this tab. But if you have any errors with installing this, if pip wasn't found, or an error in install setup, so that could happen if you hadn't set up a virtual environment perhaps, and you had an older version of the Google software development kit, the AI software development kit, and there was a conflict, say. But we're all good, so we should keep moving forwards. So now we're going to install Python, the python.env library for environment variables. So an environment variable is pretty unanimous with a virtual environment. You're going to go set up something in a .env file which holds like an API key, or I don't know, there could be usernames and passwords in there for super roles or a bunch of different stuff that you don't want to share either on a Git, like GitHub or something like that, or you just don't want it to be public. That's sort of one of the key lessons that we'll touch on a bit later on, is not sharing, like not hard coding things into a bit of software. And yeah, we're teaching this in sort of different layers. One, we're using it right at the start just to set up the script. Two, we're going to be actually writing code to detect this. And then three, we're going to be throwing some poor code at it and then seeing the result at the end. it's going to pick it up and say we shouldn't do it and give us a suggested fix. So before we write any code, let's install a package to securely manage your API key. Instead of hard-coding your key directly in your code, you'll use environment variables, which are special values stored separately from your code that get loaded when the program runs on runtime. In your terminal, type this command and press enter. So this is again just installing the python.env package. It's called .env because the folder we're about to make, file we're about to make in a second is literally .env. So here we go. Here's why you'd want to use them. Hard coding API keys directly into your code is dangerous. If you accidentally commit your code to GitHub or share a screenshot, your key is exposed. Environment variables let you store secrets in a separate .env file that you never commit to version control. This is a security best practice used by professional developers. Absolutely everyone abides by this. There's no one in any industry commits API keys or any sensitive information to a version control platform like GitHub. Really bad practice and can get you in a lot of trouble. Cool. So we're going to create a .env file. Your package is now installed. Let's create your .env file with a placeholder. You'll add your actual API key here in just a moment. So in Cursor, create a new file called .env at the root of your security scanner project folder. So not inside the virtual environment, just out here. So we're going to right click and just create a file called .env. So, right clicking, creating it, just get an empty .env file, save it so it doesn't disappear. Here's a note, never commit your env. If you're going to use this project for Git, you can create what's called a git ignore, where this would mean nothing gets committed to, and you could do really any file. There's not something which is, it's not like limited to environment files or anything. It can be any sort of folder directory you can put in there. It's not going to get committed, but env is good for that. Cool. Now let's get your actual API key from Google. So what I will do is I'll just open this up. So we can go to, depending on where you have, if you have a Google account or if you don't, then it'll be, you'll get a different screen. So you might have, it's very common to have a Google account, but if you don't, that's completely fine. There's the setup steps for getting to that point as well. So that's all good. But what I'll do is just open this up so we can follow along from where I'm at the moment. So if you saw that, I clicked on the link and I went straight to the API keys page. That's sort of this flow. Going to dashboard. But if you don't, definitely follow this. You may end up on this page here with the get started screen, and you have to go and either sign in or create an account. So yeah, that's just to be noted. But what we'll do is we'll go into get API key here, which is cool. And so in the top right, click create API key, and then we can name this as well. It doesn't actually matter what you call this. Just something, if you have a bunch of API keys for different things, then it's good to name them for, just so you understand what. Say if I was going to use another one for another type of maybe a GitHub action code reviewer, and I wanted to understand, or just have them separate for some reason. That could be understanding the usage limits and whatnot between them, but it could just be as simple as just want to know which one's being used for what. That's really the main reason you'd want to name a key something specific, but you can name whatever you want. So we can see here that we don't have a project selected. We don't have any projects at all on this account. So we'll go and select create project. Again, you can call this whatever you want. We'll just go with the my new project, but again, totally doesn't doesn't matter. So it's auto-selected the project there, so we can now create a key. Cool, so we've got our first key, my API key here, and it's under the project, my new project. Very cool. So we can open it up here. We can see the API key. Obviously this is not a functional API key by the time you're watching this, so that's why I'm not particularly concerned with sharing it, but yeah, don't share your API key online. So we'll just paste this into what's going to become our .env file shortly. So add your API key to the env file. Perfect. So let's add the actual API key to the .env file you created earlier. So we're going to paste our API key into this block. We'll copy it and then paste the code block in. We'll save it, and now we have something that looks like this. Very good. So what actually is an API key? An API key is a unique identifier that authenticates your request to a service. Think of it like a password that tells Google this request is coming from X authorized user, where X is you in this case. When you call the Gemini API, you include this key so Google knows who's making the request and can track usage. Google's free tier gives you 1,500 requests a day. If someone uses your key, their requests count against your quota, not theirs, so potentially blocking your access or incurring charges. Very true. So keeping your API key secure, don't share your API key publicly or commit it to version control like GitHub or GitLab. Anyone with your key can make requests that count against your quota. Protect your key, never commit it to GitHub. Don't share screenshots or documentation with it in it. Store it in a .env file or a secure vault. Awesome. Okay, so we've got our environment variables file set up. We've installed the packages required. So now we actually need to start writing or putting together some Python code to do the actual scanning using all this setup. Cool, so create your scanner script. Now create the main script file. In Cursor, create a file called scanner.py. Add this code to test your Gemini connection. So we're going to create a file, call it scanner.py, and we'll chuck this in here. So what are imports in Python? We see these here. Imports load external code libraries into your script. When you write import google.generative.ai, you're telling Python to load the Gemini SDK, software development kit, so you can use its functions. Without imports, you have to write all of this functionality yourself. The as gen AI part creates a shorter alias. Instead of typing google.generative.ai.generative model, you can just write gen AI.generative model. That's what we're doing here. Cool, so just scanner.py, .env, and the virtual environment folder. Let's save the file. What does this code do? This code sets up a connection to Gemini and sends a test message to verify it's working. It loads your API key securely from the .env file, initializes the Gemini model, and prints the AI's response. Let's break down each part. Import OS from .env import load.env. This imports the tools needed to read environment variables, so that's utilizing the previous thing we've just installed with pip. os.getEnv, that's getting the environment variable that we have in .env, the Google API key in this case. The configure tag sets up authentication with Google Gemini using your API key. The genai.generative model selects the model we want to use. Unfortunately, Gemini 3 isn't available on the free tier. We would be using that, but yeah, 2.5 Flash is a really good option, and it's really fast. So model.generate content sends a prompt. So we're using that. Response.text extracts a text content from Gemini's response. So that would be, plain text, and you're going to pull it out into something. You can tag there and print. So using .env and os.getEnv is a professional way to handle secrets. Your API key stays in the env file and never appears in your actual code. So alternatively, you could, and I think this is really the point we're trying to drive home here with this first section, you could write this. Forgotten quote marks. This program would function the same if you just put an API key like that, but there is a lot, like we just said, if you're going to go commit this to Git or show it to someone, then they can effectively bill your credit card if it's attached to that. Obviously ours isn't, we've a free account, so it's not the end of the world if it does, but if you had a credit card attached to it, then you could effectively be billed from someone else using it, so it's not, it's really highly advised against. Yeah, so now we're going to test our connection by running the Python script we just wrote. So we're going to run Python. So that's like effectively selecting the language. So if we see here scanner.py, it doesn't know what to run it with, even though the extension's there. So we're going to select Python scanner.py, and it's going to select Python as the language by that. So we can see here, I'll zoom out a little bit, it's a bit smaller. We're printing the response text, so as we spoke about, this is the response from Gemini, in this case to our query. So yeah, we're just getting out the output, and we're telling it here to generate content, and so we're sending the prompt effectively, say hello security scanner if you can hear me, and that's what it said in the chat. So we're good, it's connected. So if you see a different response or an error, you can go through here, but we're going to follow down the I see a response flow. So you should see Gemini responding with something like hello security scanner or a similar greeting. When you run Python scanner.py, Python executes your code line by line, sequentially top to bottom, loading your API key from env, connecting to Gemini servers, sending the prompt, and printing the response. So our connection's working, great. Cool, so we'll send a screenshot of that working. Save this to my downloads. Cool, so how did you verify your Gemini API connection is working? I verified the connection is working by running, we can put the command in here, so Python scanner.py, Gemini responded with, just copy the message, hello security scanner. Copy, that's okay. Which confirmed that the API was correctly set up and linked to Google's service. Cool, so how did you verify your Gemini API is working? I verified the connection by running Python scanner.py. Gemini responded with hello security scanner, which confirmed that the API was correctly set up and linked to Google servers. Nice. Alright, so we're actually going to test a security prompt now. Excellent. Your connection works. Now test with a security-focused prompt to see how Gemini responds. In your scanner.py file, find the the section between the two blocks. Your code goes below here, your code goes above here. Replace everything in that section with the following code. So we're going to drop in this potentially vulnerable code here. I click save, and then again we're going to run this here. Cool, so it's pointed out some stuff here. We can see that, see a bit of stuff. We'll just go to the top. Plain text storage, so we've got a password stored directly in plain text. Human readable text, there's some comments about why that's a risk and whatnot, which is great, but we can see that the security analysis is going, so we can don't have to read all of it. And if Gemini didn't flag anything, or you got an error when you ran that, you can totally go through here. So we can see, cool, it's working, nice. We'll just take a screenshot of the output there as well. I'm just saving this to my downloads again, and we will move on. How did your security prompt work, and what did Gemini detect? So my scanner.py file works by sending a prompt to Gemini with the specified code. When I ran it, Gemini identified multiple issues. Namely the plain text storage passwords of the password. Probably quite a few values. No hashing, which is a cryptography technique. And more. This shows me that Gemini API can detect vulnerabilities in my code. So how did your security prompt work, and what did Gemini detect? My scanner.py file works by sending a prompt to Gemini. Prompt to Gemini with specified code. When I ran it, Gemini identified multiple issues, namely the plain text storage of the password, hard-coded values, no hashing, and more. This shows that the Gemini API can detect vulnerabilities in my code. Awesome. So, moving on to step 2 now. Detect security vulnerabilities. Your Gemini connection is working. Now let's build a real security scanner that detects SQL injection, hard-coded secrets, and weak cryptography, the same vulnerabilities that professional tools look for. In this step, get ready to add vulnerable code examples to test against, create a detailed security prompt for Gemini, test detection of SQL injection, hard-coded secrets, and weak passwords. In this step, I'm going to I'm building a vulnerability scanner that will detect SQL injection. And we can actually ask the ask feature here what SQL injection actually is, effectively getting it to do queries you don't want to do. Someone else is going to try to do that on your system. Detect SQL injections, hard-coded secrets, and weak passwords. This will allow me to write production-ready code. So we can see here an SQL injection is a type of security vulnerability that occurs when an attacker can interfere with queries and applications. With queries an application makes to its database. So when user input, like a text from a form or search bar, is directly combined with SQL queries without proper validation, attackers can insert malicious SQL code into their input. So if it was a text box, for instance, for your username, and that was just an SQL query that just got ran, maybe that was adding it to a database. If you, with my camera over here, if you didn't have any sort of validation over that, that wasn't protected at all, then you could run something which added, say, user X as a super user to a database that gave them access to much more than they were supposed to. That's a pretty extreme example, but it's definitely that similar stuff has happened, and will continue to happen if people that aren't doing just this. Cool. So we're going to add vulnerable test code and then run the scanner on that. So let's create some intentionally vulnerable code to test your scanner. This will help verify Gemini can identify these real security issues like hard-coded secrets. In your scanner.py, add these vulnerable code examples after the model initialization, and so it's right before the code, your code goes below here section. Cool, so this has got 3 vulnerable code blocks. This is sort of like a in-between state. By the end we'll have something which can run on any file, but this is just an example of how this is gonna work in like a pretty contained environment. So we've got 3 bits of vulnerable code here, with in this case hard-coded secrets, and some more stuff. Cool, so what are these vulnerabilities? SQL injection, SQL, structured query language, is a language database is used to find, sort, and filter data. When user input is directly concatenated into SQL queries like select from users, where username is user plus, you've got an apostrophe there. Attackers can inject malicious SQL code into through forms or search bars. Your app then runs their code, letting them steal data, delete records, or bypass authentication. Hard-coded credentials, as we spoke about, storing passwords and API keys directly in source code means anyone who sees your code through a data breach, public repository, or insider access gets your secrets. Secrets being like an API key or something like that. Weak cryptography. Cryptography is the best, or it's the practice of scrambling data so that only authorized people can read it, turning something like password 123 into an unreadable gibberish. MD5 is an old method that's too weak for modern security. Attackers can easily reverse it to reveal the original password. Modern applications should use stronger methods like bcrypt or Argon 2 for password protection. Cool. Okay, here comes the magic. Now we're going to create a detailed prompt that tells Gemini exactly how to analyze code for security vulnerabilities. In your scanner.py file, add the security prompt above your code section, and after model initialization. So this is the model initialization here. Cool. So this is the prompt that's going to be sent off to Gemini. Cool. Why is prompt engineering important? The quality of Gemini's responses depends on how you structure a prompt. So by specifying exactly what you want, vulnerability type, explanation, impact, and fix, you get a consistent actionable output instead of vague responses. The code block or tag placeholder is a Python format string that will be replaced with actual code when you call security prompt.format. And you pass in the code as one of these snippets we've got here. Cool, so now we're going to test the scanner. In your scanner up here, I'll update your code section with this testing code. Cool. So we're going to save the file, and this is just printing out stuff. We'll work on this fundamentally when we're doing the adding colors shortly. Yeah, we'll be able to see exactly what's going on when we run with Gemini with these prints and whatnot. Cool. So we have this saved, and now we can go run this again. So Python scanner.py, same command as before. We'll see this print analyzing SQL example, then it's going to get the response from the model, and then print the response, which was this. It's going to do that for each of the 3 examples we have here. So you should see Gemini identify the vulnerabilities in each code example. So SQL injection in the first, hard-coded credentials in the second, and weak hashing in the third. We can go up to the top here. Cool, so we can see the vulnerability type is SQL injection. So it's pulled that up, and that's great. Exactly what we expected to happen. So it's got a hard-coded credential detection is the vulnerability type. That's cool. And then the third one, wherever it is, just here. It's an improvement. Missing password salt. Again, that's just a different type of weak hashing. A different type of saying the same thing effectively. Weak hashing algorithm. So that's cool. Picked it up. That's as expected. If you have an error, you can go down this tab here. But since we're going good, we've got detected the right things. We'll continue down this way. Cool. So I'll just take a screenshot of the vulnerabilities picked up, or one of them at least, so I can get a screenshot. What vulnerabilities did Gemini detect, and how did your prompt structure help? So the vulnerabilities Gemini detected were a SQL injection, hard-coded passwords, and poor encryption. security prompt I crafted asked for, actually, we can go look at the prompt here. Asked for a vulnerability type, why it's vulnerable, the impact, and a code fix. The structured output helps me resolve the issue, resolve the code that is vulnerable, or fix the code that is vulnerable. So what vulnerabilities did Gemini detect, and how did your prompt structure help? The vulnerabilities Gemini detected were a SQL injection, hard-coded passwords, and poor encryption. The security prompt I crafted asked for vulnerability type, why it's vulnerable, and the impact. The impact and a code fix. The structured output helped me fix the code that is vulnerable. Yeah, that's fair enough. That's a good response. Cool. Step 3. Add severity ratings and color. Your scanner detects vulnerabilities. Now let's add professional severity ratings. Critical, high, medium, and low, with color-coded output, just like enterprise security tools. In this step, get ready to install the Colorama library used for colored terminal output, update the prompt to include severity ratings, and add a function to colorize severity levels in the output. Test the scanner with colored severity ratings. What are we doing in this step? In this step, I'm setting up severity ratings which rank how severe a specific ability is. So that's, we have critical, high, medium, and low. I'm also installing Colorama to display different rankings as different colors. Cool, so what are we doing in this step? In this step, I'm adding severity ratings which rank how severe a specific vulnerability is: critical, high, medium, and low. I'm also installing Colorama to display the different rankings as different colors. Cool. So we will now install Colorama, the pip package for that. Just send that off. Cool, okay. So we've already got it installed here. So that's good. This is what it will look like if you install it in the Venv for the first time. As a matter of fact, we can probably do pip uninstall Colorama just to show you. There you go, very quick install, not much going on. Colorama is a Python package library Python library that makes it easy to add colored text to terminal output. It works across Windows and Mac. Windows, Mac, and Linux, handling platform differences automatically. Very good. So it's successfully installed. That's cool. So we're all set to go. If you get an error or pip command is not found, you can go down those tabs as well. But we're going to go on this one because we have no errors. All right. Okay, so now we're going to update the security prompt for severity ratings to add those. So perfect. Your scanner detects vulnerabilities. Now let's modify the prompt to ask Gemini to rate the severity of each vulnerability. Cool, so we've got our security prompt here. We're just going to replace it with the security prompt we've got here. Cool, we'll save the file with our updates. What do the severity levels mean? Critical, it needs like immediate fix, immediate exploitation possible. Could lead to a full system compromise. High, serious vulnerability that could be exploited with moderate effort, fixed within days. A medium vulnerability exists but requires specific conditions to be exploited. Schedule a fix soon. Low, minor issue with limited impact, fix when convenient. This classification helps development teams focus their limited time on the most dangerous issues first. So we're going to add the colored output. So utilizing this Python library we've just installed with pip, we can do some imports here. So at the top of the file, we can copy and paste that in, or just type it out. So from Colorama, we can import init. So to initialize what's called for, and then the style we want to use. And then we can initialize Colorama, and we're going to turn on auto reset to true. Cool, so we can see we're going to put it up the top. It doesn't actually matter what order it happens in or if there's spaces or not, as long as it's before anything, and definitely the Colorama import has to happen before the initialization of it. So just above your code, add this function. So, or above the your code section, I should say, which is just down here. So what are functions in Python? Functions are reusable blocks that can perform a specific task. When you define a function with def function name, you're creating a tool that can use multiple. You can use multiple times by calling it with different information. Takes inputs to do something with them. So it could be add or sum. You could do def sum, and then the function would be a plus b, and you pass a and b in, and then you'd return. And if sum was equal to a plus b, you return sum, and then this function could be used if you passed an a and b each time. You would get out the sum, whatever you return that as. That gets returned as. So in this function, we're going to be passing in text, and we're getting. Oh, cursor's trying to autocomplete for me. So we're going to add what's called a doc string here, which lets you, or which doesn't let you do anything. It lets other people do things, which is understand what the code is doing. Severity tags to the output. I won't write all of these out, but I'll just explain as I write. So we're going to replace text here. Text equals text.replace. So you can see severity critical gets severity with a tag, and the tag includes a replace, which is for red, style, bright, critical. So it's going to be the word critical in red, and style reset all, which is what we imported up here. So if we go look back, we can see we imported for style, and we've already used init to initialize So I'll just write out the first one, but then I'll just copy the rest. So if we have, we can write severity, critical, and then we can do if string here, severity, do tag for, it's called red, I think, red, and then I can do style bright, all caps, bright, and then critical has the style, reset all. And this is because this autofill feature is being annoying. Style dot reset all. Cool, so I won't do this for all of them. That's pretty bit of a pain to watch because it kept popping up recommendations on my screen like it's doing there. But yeah, we were going to replace text and then return text. So we get different colors for, so this one, for instance, for low, we're going to get we're replacing this with a severity of low there, with a color green low, and then the style reset all. So I'll just paste these in. Getting rid of the one I already wrote there, and then we're going to return it because as you do at the end of a function. Awesome. So now we're going to update the your code section to use these colors. So we're going to replace this, or we could also add to it, but yeah, we can see the output, add the colors response.txt here. In fact, we can do that just for one of these to demonstrate. So we're going to call the output. So this is a variable here. We can call the output. We can call the function with the same response.txt, which is we're getting Gemini's response, and then we're printing the output here rather than what we've called output at least. You could even call it like colored output, and then call this colored output as well. So we're going to print that, but I'll just copy and paste this entire thing in because this happened a few times, but that's all we're doing. Just making sure we actually use the our precious work up here, the function we just wrote. Cool. So we're going to save our file, Control S, close this in file as well, and then we can go into our terminal and run this again with our new colors. Oh, that may have been a thing I wrote incorrectly by hand. Let's have a look. Severity critical. There you go. I think I wrote that twice. I'll run that again. There you go. So we can see red text. It's in critical, so we know it's at the possible, or very likely the severity is quite high, so it can have a really big impact, and we should resolve it as soon as possible. So I see a colored output. You can go, if you don't see a colored output, or potentially you see something like I just saw before when I wrote the code incorrectly, where I had critical tagged twice. You would go into I got an error, or colors aren't showing up, but we're going to go through this flow for now. So you should see now a professionally formatted security report with colored severities: red for critical, yellow for high, blue for medium, and green for low. Awesome. We can have a little scroll through there. These are all critical, but if we had something less critical, it would be green or blue. So upload a screenshot of your colored security report. Awesome. Screenshot there of all I can. Just save this to my downloads folder. How did you add severity ratings, and what do the colors mean? I updated the security prompt to include a severity level. The add colors to output function works by replacing existing text with colored text using the Colorama Python library. When I see a critical red, this tells me that this requires an urgent fix. How did you add severity ratings, and what do the colors mean? I updated the security prompt to include a severity level. The add colors to output function works by replacing existing text with colored text using the Colorama Python library. When I see a critical in red, it tells me that this requires an urgent fix. Awesome. Okay, very good. So that's all of the main part of this. The next bit's going to be the secret mission, but that's been super cool. So in the secret mission, we're going to be making this a bit more applicable for real use, effectively. So like actually using it on Python files, not having to write everything in a file with these. You see here the little snippets we had. Obviously, that's not for like how you'd really use it. It'd be really useful. You could run this as like scanner.py and then pass in like the next thing would be another file name. Say in this case vulnerable.py, and then it would go and read that and then pull in information there. So ready to level up. This section is for those who want to take their skills further. So we're going to be in the user space up here. We've got a command line prompt, and we've got our, what a file it is we want to analyze. We're going to run the CLI prompt. We're going to pass in system arguments, and it's going to read this vulnerable.py, scan the file, and return file contents loaded. So this output, and it's going to give us some information around, similar stuff really around severity, type, description, etc. So what does this diagram show? This diagram shows how your scanner will work. With scanning, you'll run python scanner.py, vulnerable.py, so you're passing that second file. In the terminal, your script reads the file, sends the code to Gemini for analysis, and prints the colored security report back to your terminal. Your scanner detects vulnerabilities, hard-coded examples, in hard-coded examples, which are these snippets. Now let's make it work with real Python files, so you can scan actual code. Awesome. So in the secret mission, get ready to add file reading capability to your scanner, accept command line arguments for file paths, create a vulnerable test file to scan, and test scanning real Python files. In this secret mission, I'm adding a function to scan external files. And creating a vulnerable test file, to test with. This lets the scanner work on external files, not just stuff we pass in. Professional tools do this because because it allows developers to pass in large files, not snippets, and have them analyzed. What are you doing in the secret mission? In the secret mission, I'm adding a function to scan external files and creating a vulnerable file to test with. This lets a scanner work on external files, not just stuff we pass in. Professional tools do this because it allows developers to pass in large files, not just snippets, and have them analyzed. Awesome. Why file scanning matters. Professional tools like Bandit or SemGrep scan entire code bases, not just snippets. By adding file scanning, your tool becomes practical for real-world use, so developers can point it at the actual code and get instant feedback. So we can add, the next step is adding, or part of the step is add file scanning function, or to add that, let's add the ability to read and scan Python files. So at the top of our scanner.py, we're going to import something called SYS, so system, so that's going to allow us to interact with system files in Python. So we're going to import SYS at the top, and then below the add colors to output function we just wrote before, we're going to add this new function. So it's called scan file. It takes in as an argument the file path. What we're going to do is we're going to write a doc string here, read and scan it for security vulnerabilities. Yep. Cool. So what this, as we sort of have written in the doc string there, the goal of this function is to read a file that we pass in, so the vulnerable.py file, and go and detect whether it's vulnerable or not. So I won't write out this entire thing, but we have a try block and an accept block. File not found. So then in the try block, we've got opening the file, and if that doesn't work, then we go through the exception, and then we raise an error. Say if you're trying to search for stuff in a file that doesn't actually exist, that's when you do that. So we're going to open the file as read, save the file as variable with f.read. We're opening it as f. We're going to print, as we were doing earlier in the user code section, blocks around, just to show in chat, just this bit, or chat, sorry, the terminal window, this sort of interface, a bunch of equals. We're going to suggest that we're scanning this file path. We're going to use existing security prompt, as we already have, and then print the output. So I will just drop this in here, drop out the entire. Get rid of that guy. And then this should be file. Let's go path. Oops. That's just because I named this file path instead of file, or file underscore path instead of file path like I copied it from here. But the scan file function just takes in a file and then reads and puts it through the security prompt and prints an exception if it doesn't go the way we want it to go. Cool. So I did explain what this does, but we can read out some of this. The scan file function reads a file from your computer, sends the content to Gemini. I talked over this. But yeah, it opens it, saves this variable, generates content, and then prints that effectively. What are f-strings? F-strings are formatted string literals, let you embed variables and expressions directly inside of strings. When you write scanning file path, Python replaces file path with the actual code. If you just did say print scanning file path with the same curly braces, it would just print literally file path as exactly you've written. But in our case, file path or file underscore path for me is it's a variable we want to print the dynamic result of, and it shows here as well. You can format things. So if you wanted to add, like things, join things, concatenate a bunch of stuff together to get a certain looking like output in a terminal or elsewhere, that's a good reason to use f-strings. So now we're going to update the user code section. Now let's make sure your scanner accepts a file name from the command line. Replace your entire user code section with this. So I'll just drop that in there. See, it's a lot simpler now because we've written a function for this. So if the length is greater than 1, so has this passed? Has it not fallen into this? File path is the first thing in this index. Print scanning files at the file path, and then call scan file. Actually, sorry, I misspoke. This is the is it valid? Check if the file name was actually provided. This is there's a second exception here. It's not the same one. Apologies. Then we pass it into this function, then it does do that check, and then if it fails here, it'll explain how to use it, setup, and then an example here. So what does sys.argv do? List containing command line arguments. When you run Python scanner py .py vulnerable py comma sysargv1 index 1 is vulnerable.py, so it's effectively just scanning. Lets your scanner accept any file name as input instead of a hard-coded thing like specific test cases that we did just before. But sys.argv is a list containing command line arguments, which is why we're able to index at 1, which is vulnerable.py, given 0 position, first position. So that's where we're going there. Effectively, we're reading in this tag from this full message. This lets your scanner accept file names as input instead of hard-coded specific test cases. So now we're going to create a vulnerable test file. This is just an example placeholder in cursor. Create a new file called vulnerable.py. Add this code. Cool, we'll save the file. Now we're going to actually test it So using this code we've written. So we'll run this. So scanning vulnerable.py. Cool, so it's given us a critical severity for this, which is really good to know. And there's a high there, 2 different highs. So that's great. Awesome. So I see vulnerabilities detected. I do. You can see them there. There's a file not found. I got another error. If you run into those, you can follow down those lists. You should see Gemini identify multiple vulnerabilities in the same file, hard-coded credentials, SQL injection, weak MD5 hashing, command injection into process input. That's a function, one of these here. Your scanner is now working. You can now scan real Python files. You can see here, same result there. That's great. Okay, so we're going to upload a screenshot of scanning this file. So I'll just save this to my downloads folder and then upload it here. How did you scan vulnerable.py and what vulnerabilities were detected? I scanned vulnerable.py by running python scanner.py vulnerable.py. The vulnerabilities detected were hard-coded credentials, SQL injection, and the third one, weak hashing. The scan file function works by passing in the first index from sysargv. We'll move from the user's terminal input to sysargv1 as the input to the scan file function. That is, as I touched on before, we're taking file path from there into scan file, and then we're going and opening it, printing some breakers. Those aren't really important. The F strings, good to know. And then we're getting a response from Gemini and printing that. And if the file's not there, then we print a raise an exception. Cool. How did you scan vulnerable.py and what vulnerabilities were detected? I scanned vulnerable.py by running python scanner.py vulnerable.py. The vulnerabilities detected were hard-coded credentials, SQL injection, and weak hashing. The scan file function works by passing the first index from the user's terminal input, which is systemargv1, as the input. That says more than input for the scan file function. Cool. Awesome. What you built. Congratulations. You've extended your security scanner with file scanning capabilities. So file reading, open and read Python files from disk. Command line arguments, accept file names as input. Error handling, gracefully handle missing files. Real world scanning, analyze actual code files, not just examples. So now your scanner is a practical tool that you can use on real projects. Totally. Ideas to go further, if you want to keep building, which I definitely recommend. It's a great beginner project. You can do scanning entire directories, loop through all .py files in a folder. So if you basic for loop, it's going to just look for list all the stuff in the directory and just add those as variables and go through those at a target directory. Generate reports, so you could save. There's other Python libraries that let you save this as save it as files. That could be JSON, HTML. You could do CSV if you wanted to. If you want to do something like that, you can check out Pandas. That's a cool library for that. CI/CD integration, so running something on GitHub Actions could work pretty well. Running your scan automatically on every commit. GitHub Actions is like a far way to take this. You can run this just set up a script that does that too. Custom rules, that would update the prompt, security prompt there. Auto fix mode, so that could be definitely a bit more intense than that, but getting Gemini to not just suggest but execute fixes, effectively turning what you've got into a proper full-on CLI tool, like Ada or a very basic version of something like Claude Code. Awesome. So before you go, we'll just clean up some of the resources. Nice work cleaning the project. Let's clean up the resources we created. Resources to clean up: deactivate your Python environment, revoke your Google API key, it's optional, delete the project folder, optional as well. So you can do, if you want, you can do exit to completely close the thing, but you can also deactivate to just leave the environment, but exit also works, that closes the terminal though. What about your API key? You have options here. You can keep it and keep it safe in the file, or delete it. Totally up to you. I'm going to go and delete mine. So I'll go here and delete key. Should take a second. Cool. So now it can't be used. It's cool. You can delete this from your desktop if you want to. There's no obviously no billing tied to this at all. But if you want to, that's cool too. To wrap, you did it. You've built an AI-powered security scanner that can find vulnerabilities in Python code. Again, this is what we've built here. So the user space command line prompt we were giving there. And it's going to pick up the file here, scan the file, and based on what we passed in here with system argv, it's going to return suggestions. What you learned: how to use Gemini API to analyze code security vulnerabilities, crafting structured prompts for consistent AI responses, adding colored terminal output with Colorama for severity ratings, common security vulnerabilities, SQL injection, hard-coded secrets, and cryptography, Python environment management with virtual environments. Cool. So the tools I used were Python, Gemini, let's say environment variables, key concepts I learnt include I suppose environment variables not really a tool. It's more of a concept. Environment variables and APIs, or environment variables, good coding practices. To avoid vulnerable code, and APIs. The most important skill was, I'd say, building and understanding around why you don't want to write vulnerable code. How long did it take you to complete this project? This project took me approximately about 1.5 hours by now. Yep, just on 1.5 hours. 25 hours. The most challenging part was, I'd say, understanding how to take arguments from the terminal. It was most rewarding to see the working scanner reports on real code. Why did you do this project today? Did this project meet your goals? I did this project because I wanted to learn how to make my code less vulnerable. Efficiently using Gemini API. Using the Gemini API. This project met my goals by improving my understanding around what vulnerable code looks like and how to prevent it from getting into production. Next, I plan to improve my CLI tool by increasing functionality around how many files I can scan through at once. Cool. So we get the quiz now. What is the primary function of the Colorama Python library in the context of the AI security scanner project? To manage environment variables, to perform cryptographic hashing, to install other Python packages, to add colored text to the terminal. Looks right to me. What is the main benefit of using Python, a Python virtual environment, for a project like the AI security scanner? It automatically installs necessary Python packages. It isolates project dependencies, preventing conflicts with other Python projects. It provides a graphical user interface for managing Python packages. It speeds up the execution of Python scripts. Definitely isolates dependencies. What is prompt engineering considered? Or why is prompt engineering considered important when interacting with AI models like Gemini for tasks such as security analysis? It automatically fixes vulnerabilities detected by the AI. It allows the AI to learn new programming languages on the fly. It ensures the AI generates consistent, actionable, and structured output. It reduces the computable resources required by the AI model. I would say it ensures the AI generates consistent, actionable, structured output. What is the primary reason for storing your Google AI API key in a .env file when loaded in it with os.getEnv instead of hard-coding it? To automatically generate a new API key, to allow easy sharing of the scanner.py file, to reduce number of lines of code, to make code run faster. Effectively, I think it was definitely neither of these. Although hypothetically, you could, if you had a long enough key, would spell in 2 lines. So, yeah, this guy. In the provided context, which type of vulnerability is exemplified by concatenating user input directly into an SQL query, potentially allowing attackers to manipulate database commands? Cross-site scripting, hard-coded credentials, weak cryptography, and SQL injection. Definitely the last one. Nice. All right, cool. Let's have a look at the documentation. So, build an AI security scanner with Gemini by me, December 2025. You can replace the image or edit the text in here. But yeah, super cool. So, go introducing today's projects, tools, challenges, connecting with Gemini, verification there, some screenshots around how we did it. We can see we start adding security ratings here, and we can see actually scanning the vulnerable.py file there. We can have a quick look at the LinkedIn template. I'll just sign into my account here. Cool, so I can share this on LinkedIn. The person, whoever clicks on it, will get a really nice bit of documentation here. And also, if you just copy the URL, you can totally share this to the community or the LinkedIn, TikTok, Instagram, Facebook, Twitter, or you can download as a PDF as well. Yeah, super cool. Yeah, I think that's it from me. I think this is such a cool project. I think this is a great way to get an intro into Python as well as just understanding how security vulnerabilities work. So, yeah, super cool. But yeah, I'm going to head off now. But thanks so much for following along. See you guys shortly.